Okay, so we are talking about the language accepted by the equivalence between the language accepted by final state and the language accepted by empty string. So, just to recap, given a PDA, we have this tuple q sigma delta q 0 z 0 f. Now, now this is the set of all states, and this is the finite set of input alphabets, and this is the symbol which we are going to use in the stack symbol basically, and this is the transition rules, and this is the starting state q 0, and this is the starting stack symbol, and this is f, the set of all final state. Then we know the language accepted by this PDA in the means of final state, accepting by final state is set of all strings such that we start with q 0 with this w in the tape. So, q 0 is the starting state and the tape contain w, this is our w. So, it is pointing here, and the stack contain z 0. So, stack is z 0. If this move to the with the different, I mean with the iterative applications of delta, if it is going to a final state at the end of this execution, at the end of this tape. So, that means, if it is going to some q of f and this is epsilon, and we do not care about the stack symbol. Okay, because this is the language accepted by the means of final state, where q f is a final state. Okay. Now, this is the language accepted by final state, and now we know another way of acceptance, that is the language accepted by the with the means of empty stack. So, that is nothing but, so this is set of all w such that we start with the same positions q 0 w z 0, and we end up with a p. We do not care about final state over here, because it is just a in the means of empty stack. So, stack should be erased for any p belongs to q. So, here we do not need we do not need to reach to a final state. It can be any state. Only thing is required is the stack should be empty. So, all the symbols should be erased from the stack. Okay. Now, we will see the equivalency between these two. In the last class, we have seen the if the language accepted by this, then we have a corresponding PDA, which can accept by the means of L of means of accepting the final state. So, now today we will discuss the if we have a PDA which is accepting the language by the means of final state, then it has a corresponding, it will correspond, then we can construct a PDA which will accept the same language by the means of empty stack. So, let us try to do that. Okay. So, we want to write this in a theorem. Let L be a language such that L of M1. That means, M1 is a PDA which is accepting this language by the means of final state. So, that means, M1 is say where M1 is a PDA, say Q1 or say Q Q0 Z0 F. Okay, given this PDA. Now the theorem is telling, then we can construct a PDA M2, then there exists a, or we can construct a PDA push down automata M2 such that the M2 will accept the same language, but by the means of empty stack. So, this we want to construct. So, M2 will be accepting the same language by the means of empty stack. Okay, so, how to construct M2? So, proof is as follows. Proof is as follows. So, we have given M1. Okay. Now, M2 will take will take help of 2 extra states. So, this is our M1. In the lecture note, this is given by M2. Anyway, I mean notation does not make any difference. So, we can take M prime if you like. So, this is basically Q of will take help of 2 extra states. This is the new starting state for this automata, and this is the state which we are going to use for reaching to the final state. I mean, once we reach to the final state, we will keep on hop there and keep on erasing the stack. So, we will do that. This sigma is same, and input stack symbol we are taking help of our new stack symbol x 0, and which we are going to use for the starting state, starting stack symbol for this new automata. Okay. And delta prime we have to define, and q 0 prime is the starting state for this new automata, and x 0, and this is the empty stack. So, we do not really care about the final states. So, because this is we are accepting this by the means of empty stack. Okay. So, how we can do that? So, let us just define the delta. So, this is the n. Now, we have to define the delta hat. So, delta hat, what do we want to do? We want to first initialize this, put the x 0 there and this z 0 there. So, delta hat is like this. So, we have a rules like this R 1. So, delta hat of q 0 prime. So, we are going to start with q 0 prime with epsilon. This is the non-deterministic PDA, and the stack symbol will be x 0. Now, this will initiate the process of this M 1. So, it should initiate the process of M 1. So, this should contain this q 0, then we have z 0 x 0. Okay. So, without reading anything, we are starting with q 0 prime and our x 0 is here. So, what we do, without reading anything in the tape symbol, we just move our process to this one, that q 0, which is the starting state for this given automata, and in the stack symbol we will add this z 0. Now, z 0 is the top of the stack, which is the now this is the pointing symbol of this system, and then we have a now we are, because that is with epsilon move. So, we are not reading anything. Now, we are going to start reading this. Now, we follow the rules of this M1. Okay. Now, we reach to M1. This is the initialization process to reach to the system M1. Once we reach to the M1, then we will start applying the rules of M1. So, that we will write. Okay. So, this is just to bring it to the M1. So, now we have delta prime of any q A and any z, which is same as, now we are at M1, it will be delta, this delta of q A z and this same z, and this is true for all such q A z which are coming from, q is coming from q and A is coming from sigma star, we can say, because we have epsilon move also. Okay, not sigma star is a string. So, sigma including epsilon and the stack symbol. Okay. So, this is just the rules of, this is just the transition of the given PDA. Okay. So, we just convert this initial state to this given PDA. Now, we have a rules for PDA. So, that will continue. Now, once the W will reach here. So, we will have this. So, first we are starting with Q0 W and Z0, sorry, X0. So, now it will reach to what? It will reach to Q0 with epsilon move. We are not using W. So, this is the situation. W is here, say W is say A1 A2 AN. Okay. So, this is the tape A1 A2 AN. So, we are starting with Q0 and our stack symbol is X0. This is pointing here and it is pointing here. Okay. Now, without reading anything, we reach to Q0. Q0 is the starting symbol of the starting state of this original PDA, and then this will be Z0 X0, because Z0 is the starting symbol in the stack of the original PDA. So, it will reach to, so this will reach to here, this will reach to, we are at Q0 now and this step is remain same A1 A2 AN, and but the stack is we have X0 Z0. Now, we are pointing Z0 and it is pointing here. Okay. Now, we have a Z0 on the top of the stack. Now, we have a rules for, now once we reach here, then we will apply the rules for this. And if we keep on apply the rules for this, if the W is accepted by this, if W is accepted by this PDA in the means of final state. So, what it will, where it will go? It will go to some final state of M1 and this will be finished and we do not care about this. So, now this we have to go for another, we need to write the delta hat so that it should reach to the empty stack sense. So, that we are going to write. So, then once we see that we are reaching to a final state and this is m epsilon, then we move to a state, then this state we are going to use it, that we have to write. Then we will move to a state like this QE epsilon, and then again from QE, no QE epsilon. So, epsilon means if this is say some z gamma 1. So, this will be epsilon means gamma 1. So, like this. So, let me write this rule 3, then it will be more clear. So, idea is once we reach to any of the final state of this given PDA, then from there we will go to the some intermediate state which is QE, and from there we will keep on erase the stack symbol. So, that it will reach to a final state, I mean it will empty the stack symbol by repeatedly. So, let me write that. I just explained the idea. So, let me complete the rule. So, R 3 is basically R 3. So, delta hat of q epsilon z for any z. This contain q e epsilon for all we can write f q f for all q f belongs to f and for all z belongs to this union along with the x 0. Okay. This along with x 0. So, this will keep on doing. So, now we are reaching there. So, from there we will keep on do this. So, that we have to write delta hat of once we are in q e is the state which are going to use for erasing the stack symbols, that is all. So, q e epsilon z, this will be remain at q e contain q e epsilon. This is true for all z belongs to this. Okay. So, that is the idea, this contain this. So, that means once we reach to q e, let me just explain. So, suppose our this is empty epsilon, I mean nothing is there, it is done, and we reach to the sum of the final state. Okay. And we have still we have some symbol in the stack, say it will be x 0 will be remain here, z 1 z 2, or we can say like yeah. So, dot 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 z k, so sorry z 1 z 2 z k. Okay. And suppose at this point of time it is pointing here, and this is our gamma. So, that means what? That means this is our w, up to this our w. So, so this w is accepted by this PDA in the terms of final state. So, that means q 0 of w and this z 0 will reach to some q f, this is epsilon and this will be gamma. So, sorry, this is gamma, okay, up to this. Now, we want to this, since this is, so this is belongs to L of M 1. Now, we want this w should belongs to L of M prime, sorry, n of M prime. So, that means this w should be a string which is accepted, which should be accepted by this new PDA by the means of empty stack. So, how this will, this transaction will help us. So, this we are starting for the new, we are starting with this, we put w, we put x 0. Now, in the first step we are going here. So, q 0, then this will be remain same because we are just reading epsilon, this is epsilon, and the stacks is this. Okay. Now, we will use these rules because w is the accepted state, accepted string accepted in the means of final state. So, it will by the move relation, it will move to this situation, this ID, this instantaneous description. So, what we do? We just keep on apply this, and then it will reach to like this. We will use this q f epsilon and this z 0, this will be gamma x 0. Now, gamma is z 1 z 2 z n. So, this is nothing but, so now we will apply this rule R 3. Now, once we apply R 3, this will go to Q e, this will go to Q e epsilon, and then this is gamma is nothing but z 1 z 2 z k. So, z 1 will vanish. So, z 2 z k x 0 like this. So, this could be epsilon also, this gamma, then we have x 0. So, for x 0 also we have this rule, okay. And this will keep on doing. So, this will keep on doing by applying this. So, ultimately this will be going to the situation like this Q e and epsilon, and it will be epsilon. So, this initial ID is going to this final ID, and from here we can say this is accepting this this. That means, we are just reaching to the situation like this. This is after Q f, we are shifting it to Q e, and this is okay. This is epsilon, this is gone, already gone. This is epsilon, is nothing is there actually. Epsilon is nothing, empty, empty. And now this z 1 we have erased. So, now z 2 like this x 0. So, we will keep on do this using this rule 4 until it got empty. So, this erasing process. So, this Q e we are using for erasing this tag symbol. Okay. So, this is the idea. So, now we will see the we can this is the proof, like let us write the formal way. So, I will just give you the rough idea of the proof. So, this is the construction. Now, so we can just so we have just now we have seen that L of m, if a W is belongs to L of n, this imply W will be belongs to L of m prime. Okay. That means, so this just now we have seen, we have taken a W which is q 0 prime W x 0. Now, if this W we can go to, this is the first step with the epsilon move z 0 x 0. This is with the, we are using this rule that q prime of q 0 prime epsilon and x 0, this will contain q, and this this will be z 0 x 0. Now, since W is the acceptance state, acceptance string accepting by the final state, so it will reach to, by repeated application of delta of the original PDA, it will reach to some of the final state and some z 1, z 2, z k x 0, and this could be empty also, this could be epsilon also, we do not know. Only thing we know, q f is the final state of this. Now, we apply the rules of this delta hat. Now, it will go to, it will keep on, it will first it will go to this state, and it will keep on release this. So, in the next step it will release, it will put epsilon like this. So, finally, it will go to q e epsilon epsilon. So, this is the proof, that means W belongs to n of m prime. Okay. Now, the other way around, suppose we have a W which is, so this implies that L of m is a subset of n of m prime. but we want to show these two are same. So, for that we need to show L of m prime is a subset of L of m. Okay. So, that means if a so that means we can take a W from here L of m prime, then we have to show this W must belongs to L of m. Okay. So, how to show this? So, this is also quite trivial to show this. We can just okay. So, how to show this? So, like W is accepting this in the, so that means we are starting from q 0 and then W x 0. So, this W is accepted by this means it will reach to a state like this, some of the states we do not care about that. So, q some q and yeah some q, but we are following the rules of this. So, some q and then epsilon and this will be epsilon. So, then we can use the we can use the R2. Let me check it out. So, once we reach to epsilon, so how to justify this W is So, we are reaching to epsilon means in the middle must be we reach to this state the QF, and then this is epsilon and this has some gamma x 0, gamma could be epsilon also, and from there we can apply the our rule of this delta and we can reach to a final state of this. So, we already reached to a final state, so that is it, that implies W belongs to L of n. So, that means L of n is a subset of this. So, this means L of m prime is equal to L of n. So, this is the proof. Anyway, the proof formal proof will be given in the lecture note. Thank you.